Good day, everyone. You are welcome back to the class. My name is John. Today, we are looking at how we can apply the laws of indices that we learned in the last class. So, we are going to see how we can use these indices to solve problems, how we can apply each of these laws which you have already learned. So, let's quickly take the first example. Question 1. Evaluate So I have evaluate 2a square times what? 4a cube. Now, based on what we have learned, what law are we applying here? We are applying what? Good. We are applying multiplicative power law. So let's see how we can use this law to quickly solve this problem. We have 2a square times 4a cube. We bring out the numbers together. So we have what? 2 times 4. Then times what? A square times a cube. A cube, that is a raised to power 3. Do you understand? So here, 2 times 4 is what? 8. Then times, remember that when the bases are the same, you pick one and add the power. So we pick one of these a, so it will be a raised to power what? 2 plus 3. So it will give us 8 times 2 plus 3 is 5. Good. That is a raised to power 5. So the final answer will be what? 8a raised to power 5. You can see it is as easy as this. Do you understand? Now let's quickly take example 2. Example 2, how we can apply the laws of indices. Simplify. Simplify 2a cube, all in brackets, raised to power 2 times 4a raised to power 6, then all in brackets, raised to power minus 2. Now, if you look at this, you will see that the powers are 2 in this case. So what law are we applying here? We are applying product power law. We are applying what? Product power law in this case. And then here we are applying the negative power law and the product power law at the same time. So you see now we are going to combine 2 or 3 laws to solve a particular question. Let's see the solution quickly. Two a cube all raised to power 2, 4a raised to power 6, then all raised to power minus 2. So these two, because they are in brackets, these two will also affect this 4. What it means is that these two will be what? 2 square. Then these two also will affect this a. So here now we're going to have 2 raised to power 2, which is what? 4. So we have 4. Then because of this product now, we have A raised to the power what? 3 times 2, which will give us 6. Do you understand? Then we come here, we have minus. Remember I told you minus will be what? Reciprocal. So here now it will be 1 over 4a raised to the power 6, then all raised to the power what? 2, because of this minus. Are you following? So let's quickly finish this. So we take this one to be 4a raised to the power 6 times 1 over. Now, remember these 2 also will affect this 4. So it will be 4 square. 4 square give us what? 16. So we have 16. Then 6 times 2 will give us what? 12. Good. So we have 16a raised to the power 12. So the final answer will be what? 4a raised to the power 6 times 1 will still be the same. So it will be 4a raised to the power 6 over 16a raised to the power 12. All right. So because you are having 4a raised to the power 6 and 16a raised to the power 12, we have to work on it further. Do you understand? So to work on it further, 4 divide 16. This here will be what? 1. 4 divide 4 is 1. 4 divide 16 is what? 4. So here now, 1 times a raised to the power 6 will give us what? A raised to the power 6. So we're having a raised to the power 6, right? Over, here now we're having 4 times a raised to the power 12 to now be 4a raised to the power 12. You get it? Now, we are still going to apply, here now is division. So we are going to apply division power law. We pick one of these a. So the answer now will be, it will now be a raised to the power 6, division change to minus. Change to what? Minus. So it will now be minus 12. Do you understand? Then all over what? This 4. What do we have now? 6 minus 12. What will it be? Minus 6. So it will now be a raised to the power minus 6 over 4. Now, this is the same thing as 1 over 4 times a raised to the power minus 6. Do you understand? 1 over 4 times a raised to the power minus 6. Now, we are going to apply negative power law here again. So it will now be 1 over 4 times 1 over a raised to the power what? 6. I hope you are following. So now our final answer will be 1 times 1 is what? 1 over 4 times a raised to the power 6 will give us what? 4a raised to the power 6. So here will give us our final answer. I hope it's clear to every one of you. Good. So from all we have done, I want you to try this and see how far we go. All right? All right. We are looking at the second aspect of the application of the laws of indices, which is exponential equations. Which is what? Exponential equations. Now, exponential equations, they are also called exponential functions. They are equations having the unknown as power or index or exponent. Now, in this case, the unknown such as x or y or m or any letters, instead of being at the base, at this point is going to be at the power section. So that is why I call it what? Exponents. Let's quickly look at some examples of exponential equation. Some examples of exponential equation. Number one, we have 2 raised to power x equal to 8. Can you see now? So this x is the unknown, and you can see it's now the index or the power, or you can call it what? Exponents. Now, how do we solve this? We have 2 raised to power x is equal to 8. It's very simple. All you just need to do is to raise them to the same base. How many 2 can we get in 8? 3, correct. So we have 2 raised to power x equal to 2 raised to power 3. So at this point, all you need to do is just to equate their power. So the base cancel the base, therefore x is equal to 3. Can you see how simple it is? So let's go to example 2. Example 2. Example 2. We have solve for raised to power x plus 1 equal to 2 raised to power x minus 1. So again, we are going to raise them to the same base. 4 and 2 will be brought to the same base. So what do we do now? Solution. I hope you are following. 4 raised to power x plus 1 equal to 2 raised to power x minus 1. So how many 2 can we get in 4? 2. 2 raised to power 2 give us what? 4. So we have 2 raised to power 2 bracket x plus 1 equal to 2 raised to power x minus 1. And like I said before, 2 will cancel 2, you equate their power. So we're having 2 bracket x plus 1 equal to what? X minus 1. I hope you're all following. So we use this tool to clear this bracket. What that simply means is that we use this